Okay, so magandang araw. So this time, ang topic naman natin ay infinite geometric series. That means we are going to get the sum of the terms of infinite geometric sequence. So walang katapusan pag sinabing infinite. So is it possible to get the sum of an infinite geometric sequence? Walang ang katapusan yung terms. So let's find out. So halimbawa, 2, tapos 4, tapos 8, 16, 32, 64, and so on. So, pag kinuha mo yung sum, no, 2 plus 4, 6, plus 8 is 14, plus 16 is 30, plus 32 is 62. Palaki ng palaki. So, is it possible to get the sum in that sense? Kung palaki ng palaki and we do not know where the sequence ends. So, in that case, hindi talaga possible. It's not possible. But, it would be possible to get the sum if the ratio is lesser. Now, ano yun? So, paano yun? Let's find out. Okay, ganito lang yan. So, if we have a geometric sequence, a sub 1, a sub 2, a sub 3, up to infinity, okay, with common ratio r, then the sum of all the terms of the sequence exists. Yon, pwede pala. If, and only if, so this is the condition, the ratio is between negative 1 and 1. Meaning, kapag nakasulat sa fraction, proper fraction. If the ratio is proper fraction. Pag nakasulat sa decimal, 0 point something. So, negative 0 point something or positive 0 point something or proper fraction. Otherwise, hindi natin pwedeng kunin ang ratio. Ang sum, rather. For example, ito, the ratio here is 2. Since the ratio is 2, then we cannot get the sum. But if the ratio is 1/2, yon, pwede natin kunin yung sum. So, how do we do it? We will use this formula. So, the sum up to the infinity is equal to a sub 1 over 1 minus r. Okay, so a sub 1, that's the first term, over 1 minus r. The ratio, r is the common ratio. So, remember that the sum of an infinite geometric series does not exist if r is greater than or equal to 1 or if r is less than or equal to negative 1. So, only the ratio that belongs to this range. No, kapag nandito yung ratio, yun, makukuha natin yung sum up to the infinity. So, let us evaluate the infinite geometric series. 1 plus 2 plus 4. So, first, you have to get the sum para ma-check kung solvable ba o hindi. So, or rather, the ratio. Clarification, you have to get the ratio first to check if this is solvable. So, since the first term is 1, the second term is 2, the third term is 4, so the ratio would be 2 over 1. So, 2 over 1 is 2, and 2 is greater than 1. Therefore, the sum does not exist. So, simply write no sum, or the sum does not exist. Okay, next, let us have number 2. So for number 2, we want to find the sum of the geometric series 48, then negative 24, then positive 12, up to infinity. So remember, the ellipsis indicates that the term or the sequence is infinite. So let's check for the common ratio first. So let's get the common ratio. So we could divide consecutive terms. So pwedeng ito sa ito. So right divided by that. So 12 divided by negative 24. By simplifying this, divide by 12. So this is 1, this is 2. So the common ratio is negative 1. So is this a proper fraction? Since this is a proper fraction, therefore the ratio is really between negative 1 and 1. So therefore, the sum exists. So let's solve for the sum. So the sum up to infinity is equal to a sub 1 over 1 minus r. So the first term, 48. So 48 over 1 minus, the common ratio is negative 1. Do not forget the parentheses. since the ratio is negative. So 48 over, this is minus negative, so that becomes 1 plus 1 half. So do not forget, remember the shortcut in adding whole number and fraction. So 2 times 1 is 2, plus 1 is 3. So that would be 3 over 2. So remember the rules in dividing fractions. So get the reciprocal of the denominator and multiply it to the numerator. So we have 48 times 2 over 3. I think we could simplify 48 and 3. So 48 divided by 3, so that would be 16. So therefore, the sum up to infinity is equal to 16 times 2, and 16 times 2 is 32. So the sum is 32. That's it. Very simple. Now, let us try to answer this problem. So this is 16 plus 1.6 plus 0.16 plus 0.016 plus and so on. So let's check for the ratio first. So let us get two consecutive terms. We have then divide it from the right to the left. So we have 1.6 divided by 16. So since we are dealing with decimal, so para maging fraction yan, so just move the decimal point. The technique is, since we have here one decimal place, then you have to multiply this by 10. One decimal place, multiply it by 10 para matanggal yung decimal. Or kung 2 decimal places, multiply it by 100. Kung 3 decimal places, multiply it by 1,000. But since we multiply the numerator by 10, so we have also to multiply the denominator by 10. So this now becomes 16 over 160. So the ratio is 16 over 160. Let us simplify. I think this is divisible by 16. 16 divided by 16 is 1. 160 divided by 16 is 10. So therefore, the common ratio is 1 over 10. Or we can use the decimal 0.1. So you can use 1 over 10 or 0.1. Now, since the ratio is between negative 1 and positive 1, then the sum exists. So let's solve for the sum up to infinity. So that would be a sub 1 over 1 minus r. So the first term is 16. So we have 16 over 1 minus, we could use the fraction or the decimal. So let's use the decimal. Minus 0.1. So this is 16 over 1 minus 0.1. That would be, sige, para dun sa iba nahirap mag-minus. 1 minus 0.1, that would be 9 over 10 or 0.9. So 0.9. Since we have a decimal in the denominator and we have here one decimal place, so let's multiply this by 10 and also the numerator by 10. So we could get rid of the decimal number. So this is 16 times 10, that's 160, and 0.9 times 10, that would be 9. Therefore, the sum up to infinity is 160 over 9. And that's it. That's the sum. Okay, now checking using the calculator. So if we used 1 over 10, so the sum up to infinity would have been 16 over 1 minus 1 over 10. So let's check the value using the calculator. So we have fraction, 16 in the numerator, and 1 minus 1 over 10 in the denominator. So let us see if this is really 160 over 9. And that's it. So this is 160 over 9. Okay, so it's very easy. Now you can answer number 4. So evaluate the infinite geometric series 2/3 plus negative 4 over 9 plus 8 over 27 plus and so on. Always remember, check first the common ratio. If the common ratio is between negative 1 and 1, a proper fraction, or a decimal starting with 0 point something, then that would be existing. The sum would be existing. But if the ratio is greater than or equal to 1 or less than or equal to -1, then the sum does not exist. Okay, so that's it. Okay, so magandang araw ulit sa inyo. Now, we have the extension of infinite geometric series, the part 2. So, remember that if the ratio is greater than -1 but less than 1, the sum exists, and the sum is given by the formula s up to the infinity. The sum up to infinity is equal to a sub 1 over 1 minus r. Now, applying this, let's try to solve for the following problems. Find the specified unknown in each infinite geometric series. So it is given that the series is infinite. So we have the sum up to infinity, we have a sub 1, we want to determine the common ratio r. So how do we do it? Simple. Just substitute everything to the formula. So from the formula, s up to infinity is equal to a sub 1 over 1 minus r. So the sum is 45 equals, the first term is 15 over 1 minus r. Okay? Now, so we have 45 equals 15 over 1 minus r. So we need to get rid of the denominator. So what we are going to do is multiply both sides of the equation by the denominator 1 minus r. 1 minus r. Para ito ay makancel. So we have now 1 minus r times 45 equals 15. So distribute 45. So we have 1 times 45 is 45 minus r times 45 is 45r equals 15. Now by APE, we have negative 45r is equal to 15, then minus 45. So we have negative 45r is equal to 15 minus 45. That would be negative 30. Yes, negative 30. Divide both sides by negative 45. This would be cancelled. Also the negative signs. We could cancel the negative sign. So the ratio would be 30 over 45. So just simplify the fraction. I think we can divide 30 and 45 by 5. So 30 divided by 5 is 6. 45 divided by 5 is 9. But as you can see, 6 over 9 is still simplifiable. We can divide both 6 and 9 by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. So therefore, the common ratio that we are finding is actually 2 over 3. That's simple. Madali lang. No, kayang-kaya. Now, I think you can answer letter B on your own. No, that's for your practice. Now, let us try to answer number 3. Let's try to answer number 3. So, in number 3, the sum of an infinite geometric series is 72. So, let's write the given. So, the sum up to infinity is 72, and the common ratio, that's r, is 5 over 6. So, we want to determine the first term. So, let's find the first term. So, since this is sum up to infinity, then we shall use the formula s up to infinity equals a sub 1 over 1 minus r. So, 72 is equal to, our first term is missing, but we have the common ratio 1 minus, so the common ratio is 5 over 6. So, we can simplify first the denominator. So, we have 72 is equal to a sub 1 over, so remember the technique, 6 times 1 is 6, minus 5 is 1 over the denominator 6. So when we are dividing fractions, remember to get the reciprocal of the denominator and multiply it to the numerator. So 72 is equal to a sub 1 times the reciprocal of 1 over 6 is 6. Now, to solve for a sub 1, simply divide both sides by 6. So this is cancelled. So therefore, a sub 1 is 72 divided by 6. So what is 72 divided by 6? That would be 12. So the first term is 12. That's simple. Now, I think you can answer now letter B and number 2. That is for you for more practice. Okay, thank you.